Good afternoon, ladies and gentlemen. My name is Jan Stępień. I work in Munich, Germany, at a company named stylefruits. We are an online fashion and interior design hub. We are on 5 European markets in Germany, France, Netherlands, UK, and Poland. To give you a sense of scale, we are dealing with 10 million monthly unique sessions, half of which is in Germany. We used to be a purely Ruby on Rails based company, but we've been gradually migrating to Clojure, and that's what I'd like to tell you about in this talk. Let's start at the beginning. It was 2008 when the first version of stylefruits was built in Ruby on Rails 2.1. It took 3 months to get it done. It's kind of customary to compare software architecture to various dishes. We've heard about spaghetti code, we've heard about baklava-like architecture with too many layers. I think it would be fair to compare this application, which took care about everything in the company, to a famous South German/Austrian delicacy, Leberkäse. Just like Leberkäse, our application was monolithic, with bad separation of concerns, and wobbly. If you are more familiar with Polish cuisine, a good comparison would be pasztet. Niezły pasztet. So yeah, this is how our code looked like. It worked quite fine. Scaling problems were solved by horizontal scaling and caching. It all went like this with side projects done in Ruby or JRuby until 2011, when something interesting happened. One of the engineers who was supposed to develop another side project decided to pick a risky path and implement it in this exotic new niche language called Clojure. This wasn't met with a cordial response of the head of engineering. But the argument, look, it's 100 lines of code. In the worst case, I can rewrite it in 2 days, settle the issue, and the first piece of Clojure was deployed to production. In fact, it's still running somewhere out there. Since 2011, it had roughly 15 minutes of downtime, 10 of which occurred when whole AWS Europe was down. So this set an interesting precedent for us, right? This demonstrated that Clojure is a viable, maybe not alternative, but solution. Let's return to our main application. Features on top of features, layers on top of layers, things weren't getting better. And it's not Rails, in fact. It's just the fact that all time was dedicated solely to feature development. The company's future wasn't certain, so you know, adding features, no time for refactoring, that's how it ends up. It was getting in a worse and worse state, and everybody saw consequences, right? Features took longer and longer to deliver. Load times suffered terribly as well. We needed something new, some solid alternative. And the idea was based on a following observation. Take a look. This is our Polish version, one of our pages. If you take a look, the observation is following. The page is built from independent parts, independent chunks which do not share any data and can be rendered independently. You can see the header, left navigation with various filters, the main content, sorting filter, pagination, right? Independent things. And based on this observation, the company came up with the idea of widgets. Independent chunks upon which the whole app should be based. The next step was obvious, right? Feature freeze and dedicating all engineering force on getting the rewrite done as quickly as possible. This is exactly what has not happened. The rewrite, partial rewrite to the new architecture, gained acceptance of decision makers under the condition that it will not interfere with daily development activities. Based on this constraint, the following architecture, to use a bold word, was conceived. The new app was supposed to just run side by side with the old one, sharing code responsible for data access and business logic, and serve gradually more and more requests depending on our progress of porting pages from the old to the new app. This didn't work out pretty well. People working on it quickly found out that the code for data access is not that useful because of coupling to the rest of the app and general bad state. So it was the idea. The next step was to build a new independent library. We've heard about the repository pattern in the morning today. This library was supposed to serve as this repository for data access. And it was everything Ruby. Unfortunately, this wasn't the final state we found ourselves in. We had to complicate things a bit by making Ruby on Rails take all requests. The reason were our routes. They are a bit complex and require access to database to make a decision which controller, controller should take care of rendering a particular request. This forced us to, at least for the time being, to have all requests served by the Ruby on Rails application, and in one of the first middlewares to make a decision which app should respond to this request, and if necessary, send the request to the new widgeting application. The rewrite started in 2012, and quite early in the process, another insane idea popped up. Look, how about rewriting it all in Clojure? Right, we have this piece of code running somewhere there, which is performing really well. We have, well, we like it, right? We hacked a bit back home, and it seems kind of reasonable. And also, there is very nice library for templating called nlife. Maybe we can try it out. I will talk about nlife in a second. And this is how the whole thing ended up being. This is pretty much how our stack looks like. What's interesting is the fact that the Clojure application and this data access library written in Ruby are running in a single JVM. And surprisingly, the interop between JRuby and Clojure in this VM is just flawless. It's just separated by a thin layer of code responsible for translation of data structures back and forth, and they just work really well together with each other. Now we know how we ended up in the state we're in now. I'd like to dedicate the rest of the talk to telling you about some observations and well, our experiences in the whole process. I'd like to begin with immutability. This might be counterintuitive. This doesn't sound that impressive, right? You can just freeze all the values. All immutability is, let me show you an example. This is a Clojure REPL. Let's define a vector, right? 1, 2, 3. We can print it, 1, 2, 3. Using the conjoin function, we can add 4 to the vector. We have 1, 2, 3, 4. Print the original version, 1, 2, 3. It's unchanged. Now you know everything there is to know about immutability, right? Every single data structure in Clojure, every single value, with some minor exceptions, is immutable. This doesn't seem that critical, but as I'll try to demonstrate in a second, this was one of game changers to us. Now let's talk about those widgets I mentioned at the beginning. They were this cornerstone on which the whole application was based. Widgets are essentially two functions, like in this hash map you see here. This is a simplified, not that simplified widget. It's just a fetch function responsible for getting the data necessary to render a page given the request environment, and view function, which is fed with the data from the fetch function, and is supposed to return a abstract representation of the HTML of the resulting page, of the resulting widget, excuse me. Why separate into two functions? The point is that the first function is supposed to make some kind of I/O contact with our data sources, be it database, Solr, Redis, anything else, while the second function is supposed to be pure, as in for given arguments, it should return only the return value, always the same for given arguments, and shouldn't alter the state of the application in any way. This, combined with the fact that everything we throw into those widgets, all the data we throw inside into those functions is immutable, makes reasoning about the whole widget-based system much easier. We don't need to worry at all about what's happening inside, how the data we have is shared between different widgets, because they can't change it. If they can't change it, they can't break anything, in theory. There's another interesting thing, also a result of immutability. If you were to simplify our whole rendering pipeline, it looks like this. We know the map function from Ruby, right? We just map the render function over the collection of widgets, and we get rendered widgets as a result. Thanks to the fact that those widgets are independent from each other, and what they share is only immutable data, we parallelize the whole process with just replacing map with pmap, which is just a parallel, multi-threaded, using a thread pool, version of map. And this is how the entire diff in a commit looked like. The commit said, make rendering parallel, and that's it. We didn't need to change anything else. It just worked out of the box. And now widgets are rendered in a thread pool, each of them separately. It's just wonderful. The simplicity you get as a result. Now let's talk about templating. Templating was our major pain point, right? We had those huge templates which weren't, well, they were a product of years of technical debt. And we wanted something rock solid, right? Our templates looked like this. I have to admit that comparing it to Lebekeze works better at every step. This really was a mess. And nlife, I mentioned before, was supposed to solve the problem we had. What nlife is a simple library giving you an abstract representation of the HTML. It looks pretty much like this. It's a simple hash with some vectors inside, nested structure. It also gives you a set of functions which allow you to transform this representation, modify it, and a simple CSS-based selector language which simplifies the whole process. You just use CSS selectors for everything. What's important is the fact that our templates are all stored as pure HTML without a trace of templating language, DSL, inside. People at stylefruits who are responsible for frontend are in their natural habitat. HTML, CSS, nothing else. Afterwards, the application, nlife, during its startup, it translates all those HTML files into those data structures you see here. As a result, programmers deal just with pure, simple data structures and operate on them. And those widgets I mentioned before, all they do is they transform those data structures, fill in with data from the database, add interpolation strings, then the whole rendering pipeline builds all the rendered widgets in the whole page, renders to a string, sends to a user. Works very well. And at least from our perspective, it's just easier to deal with. REPL is something which is available nearly everywhere nowadays, right? The read eval print loop has been in Ruby for ages, IRB, then Pry. Python has it always had it. In the browser, we have a JavaScript REPL in the developer tools. So back to our example, it doesn't seem any different, right? But there's one important game changer. It's called nREPL. nREPL is basically a REPL over TCP/IP. All our development machines, well, all our application instances expose this open nREPL port to which you can connect your REPL session or your editor, Vim Emacs. Your development day looks pretty much as follows. You start up a instance of this Clojure application, unless you have one running since yesterday. You plug in your editor, and from then on, you edit code not on disk, but within this application, right? Full immersion in the state of the virtual machine. You can inspect the state of the machine. You can modify functions at a single function granularity without affecting the rest of the VM. This is amazing. You can change everything from views down to routing and middleware stack. Everything is just pluggable. In the same VM, you can load your entire test suite, run it within the same VM. You just don't restart, right? There is no waiting time. It's distraction-free environment. Another interesting fact is also nREPL availability on production machines. So if things get really bad, we can nREPL into production machine, patch a function or two there, and have something quickly fixed without affecting the rest of the app. That's something we try not to do, but sometimes it happens. So yeah, this was a major game changer to us. JVM gives us quite solid performance, but when performance is lacking, we have good tools to tackle it. That's another nice side effect of switching to Clojure, right? All the profilers, heap analyzers, originally developed for Java, work like a charm in this case. Stack traces generated by Clojure require some practice to get used to, but it's just a matter of practice. Another wonderful thing is the Clojure community, and I'm talking about the level of professionalism. I'm talking about the level of discussion you see on forums or, I don't know, pull requests, respect for backwards compatibility, semantic versioning, quality of tools. Also the fact that those libraries we've got there, they usually solve just one problem only. Right? Small, very focused libraries. That's something which is just useful. Also, since we're running already 2 languages in one VM, right? Clojure and Ruby. And thanks to JVM, we also have access to any Java, Scala, what have you, piece of code. We have much broader choice when it comes to ready off-the-shelf solutions, which we can use to solve our problems. This significantly broadens our choice. Ruby surely has a much broader ecosystem of libraries, no doubt about that. But Clojure, I'd like to underline here, is doing quite a good job when it comes to assuring that you have access to, say, drivers for some exotic databases, etc. This is really really good. It's of course not all moonlight and roses, right? We made a lot of mistakes. Since the application I'm talking about was our first large-scale Clojure application, we were still not using things which are considered idiomatic in Clojure. We were making a lot of other mistakes, things just writing code which you're not supposed to write in this language. We are steadily eradicating those code smells, getting rid of them, but there is still a lot to be done. An interesting side effect of the transition to Clojure was hiring. I think we can all agree that hiring in software development isn't an easy task. It's not getting any easier if you're using an exotic language. But there's one interesting observation. Having Clojure written in our job adverts works as some kind of a filter. It seems that if you advertise that you are hiring for Clojure purposes, it works as a magnet for people who are more open-minded, willing to learn more, being bored with what they did before, and want just, open for new ideas. Brain like a sponge. Wonderful. We have an interesting mix of people in the company, right? We have people from enterprise, large-scale banking, Java. We have some Django hackers knowing everything about Python. We have Rubists. It's an interesting mix, right? A lot of interesting ecosystems just cross. So that was very interesting side effect of picking Clojure. There is still a lot to be done. Our initial plan, like large-scale vision, was to have all those widgets completely separated into a network of microservices, right? Each widget being a tiny microservice, just responsible for a single widget, load balanceable. This is of course, just dreams for the future, but we still have a lot of things to be done in the existing code base as well. As I said, getting rid of the code smells we introduced at the beginning. And if I was to sum it all up, I think we did a good decision, because not only we got this very different development environment, as I said, distraction-free, with really solid tools, good support of editors, profilers, etc. We got an interesting mix of people who work on this system now. In fact, no new project nowadays is being started in Ruby. Everything by now is being started only in Clojure. There is the old application is still there, still serving a lot of requests. We are far from the end of the whole migration. But we are slowly cutting out responsibilities from this huge application. For example, backend data processing, which also used to take place in this old app, now is moved to a separate network pipeline of tiny Clojure projects. So this had a really huge influence of us, and all I can say is consider migrating to Clojure. It's just so much fun and worked great to us. I barely signaled most of the topics, most of the interesting facts about how it all worked for us. So I hope you will just fill the gap now and ask me about things which you're more interested in. If you're not willing to ask questions now, you know how to get in touch with me. And that's all I've got. Thank you all very much.
Questions?
I just got a short question. You mentioned at the end about the pipeline of lots of small Clojure apps. Now, is that all over HTTP, or do they run in one JVM, or how do they communicate?
We mostly use AMQP on top of RabbitMQ for those purposes. I don't think we have anything communicating actually internally over HTTP. AMQP mostly.
Can you compare productivity? So how many features can you deliver using current approach in comparison to the previous one?
I think it's unfair to compare, since it would be comparing a huge, monstrous legacy app and productivity there versus something brand new and shiny without any technical debt. So I think any comparison would be unfair against Rails.
You changed Ruby to basically JVM, right?
Yes.
What's the the change of the maintenance costs and servers and so on, because Java is treated as a heavyweight environment. So what's your point of view of that?
If I remember correctly, the numbers we used to run 1 year ago, 1.5 years ago, we used to run 50 or 60 Ruby servers to tackle with the load. Now we are running roughly 12 JVM instances on same AWS boxes. The traffic in the meantime has doubled, and those machines serve most of the traffic with most CPU-wise expensive pages. So I think it's a win when it comes to performance, broadly understood. When it comes to maintenance, our deployment changed a bit. It's interesting because we have those both Ruby and Clojure files in the same archive. We're just building a massive jar with everything inside, with some hacks on top of Ruby load path, so that when we spin up this JRuby context within our application, we set the load path correctly so everything loads at the very beginning, and then we just throw the jar on the servers. When we start it up, it starts this Jetty server, and that's it. We're not using any application server, say Tomcat or anything like this. Yes.
Okay. Hi. When you have the idea of splitting the whole page to the hello.
Sorry. Hey.
I'm here. When you have the idea of splitting the whole page to the widgets, haven't you thought about generating HTML within the browser using, I don't know, HTML handlebars or something like this?
If I remember correctly, that solution wasn't acceptable for SEO purposes. But I might be not up to date with what is possible. So if you can add anything, or we can discuss it later, I'll be happy to get into details. Yes.
So my question is, because Clojure and Ruby, they are completely different languages. And also when you write the code in Clojure and Ruby, you have to think completely differently, right? So how does it feel to develop at the same, like maybe not at the same time, of course, but how does it feel to switch all the time between these two languages?
That's a great question. On one hand, they aren't different, right? They are still dynamically typed languages with Ruby, apart from its strong object-oriented heritage, still has a lot of those functional things inside, say blocks, operations on collections. But yes, I have to admit that especially people who are joining the company and familiar with Clojure yet, take some time to get used to how functional idioms work in comparison to object-oriented ones. Code reviews helped a lot in getting started. And I think if you look at how our nowadays contemporary Ruby code looks like, you would be surprised. I mean, we're doing a lot of functional, or at least inspired by functional Ruby nowadays, but the mindset when you switch from Ruby to Clojure because you have to get something done in both languages, it's not such a shock. I think you can get used to it. Yes?
Hi.
Hello.
Here. Okay. What I don't understand, what was the main reason you thought that you are not able to scale more with Ruby on Rails? Because I know a lot of projects which are, from my perspective, bigger, like Shopify, for example, and they still goes on Ruby on Rails and it's fine.
I'm certain that if this code base was rescued earlier, or if the team who was supposed to rescue it was just better, it would still be Rails, right? This code wasn't in a shape which was just, unable to revive. there surely were ways, but I think people who made the decision about the rewrite, about the complete rewrite, just were fed up, to put it honestly. And in the end, it seems that for us, I'm not making a general claim, Clojure is a language in which modeling things is simpler when it comes to thinking, right? We are simple people. We think about simple things, and Clojure promotes this approach. Yes? Yes?
The advantages in hiring you talked about are compared to what? Because I got the impression you could, I have heard the same story about people who said we put Ruby in the hiring or the job adverts.
Well, compared to before we put Clojure in our job adverts. Well, we just didn't have Clojure. I'll be happy to talk with you afterwards. Anything else? I love questions, honestly. Also via email. Yes, here.
But do you still like Ruby?
Oh, I do, sure. Honestly, I mean, if I have a problem to solve, then Ruby is in my top 3 candidates to get it done, right? Just next to Haskell and Clojure. Any other questions?
Yes, this might be a really, really hard one. So what about the syntax? I mean, Clojure is Lisp, right? So there are a lot of parentheses. And how do you deal with this? Because a lot of people here will probably think that this is impossible to write in that language. And as you probably, not probably, you said so. So you know Ruby well, and you know Clojure well, so you can be, some advocate for the Clojure to the Ruby community.
Well, your question is very well grounded, sure. But to be honest, I mean, I can't see parentheses any longer, right? For me, it's just blocks of code in blocks of code. It's just nested code structures. The problem of typing parentheses doesn't exist because we have editors, right? Vim, Emacs are well suited, with some plugins, are very well suited to Clojure editing. They will take care for all parentheses in a proper place. They, if you really like, they will just color parentheses matching with different colors of the rainbow. Your code looks just amazing when you look at it. It's just rainbow everywhere. I love it. And it helps a lot at the beginning, right? Because you see, this doesn't match. When it comes to structure, it's different, right? It's not a, well, it's not Ruby, that's for sure, right? It's different. But then again, it's nothing you wouldn't be able to get used to and to learn just by practice, getting comments from your colleagues. We, not long ago, hired a Python programmer. He struggled a bit at the beginning, that's certain. But afterwards, I mean, he just became fluent in the editor he used. I'm not sure which one was it, but it doesn't matter. And he became productive. It's just a matter of time and a small change of the mindset, right? You have to unlearn some things, start again, and boom, you're productive again.
Well, the thing I just wanted to continue on this a little bit, because I've played a little bit with Clojure.
All right.
And the most frustrating thing was that I cannot comment out one line. Because if I do this...
Let's talk in a second.
Okay.
Yes, I see. Hello.
Hi. So you came to a Ruby conference and you were talking about going to Clojure. That's not good.
Thank you very much.
Just kidding. My real question is, I want to expand on the why. Do you think that programming in Clojure gives you more joy than in Ruby? Because that's my main reason to program in Ruby.
To each his own, right? Or her own. It's all about matter of taste and what tools suits your mindset. I think that Ruby is perfect for one group of people. Other languages are perfect for other groups of people, and some people just solve all problems in Haskell, right? And they are just amazingly productive in it and are able to do crazy things and smile during doing it, right? So it's all just a matter of taste, I think. I'm not, as I said, making a claim that Clojure is superior, that
just kidding.
Things, right? It's all about picking your own tool for your own battle.
So
yes.
Functional programming definitely gives you like this different mindset, and I really like what you said about Clojure, and recommending basically simple data types. So you've got a lot of production experience with both Clojure and Ruby, and my question is, how do the tests look? Do you write less tests? Do you write more tests? Do you write different tests?
It's great that you asked this question, because you reminded me of a very interesting podcast episode I just heard. It was Functional Geekery is the name of the podcast. Functional Geekery is the name, and they started with a C# note, because on the first episode they had Uncle Bob Martin, and they had a 1-hour episode just about Clojure and functional programming. And he, as a strong proponent of TDD, claimed that REPL in Clojure doesn't make you abandon TDD, but significantly reduces your interest in it, because you can try everything live in the REPL. So I don't think that removing tests is justified, but the REPL changes a bit the way you tackle problems. That's granted. I hope that more or less answers the question.
Do you write tests or not?
We do. Okay. I see a question there.
Okay, so on Clojure testing, do you write isolated tests in Clojure? Because I found that in the community they often use integrated tests to test their applications, claiming they're simple and that's enough.
We have small unit tests. Actually, most of what we have are small unit tests.
I mean, you can unit test your functions, but then you have the integration between your, controllers, whatever they're called, and you can isolate yourself from those functions, or you can use the real ones. And do you use that isolation based on mocking and stubbing in Clojure?
I think we use this approach inspired kind of by dependency injection in a way, by having the Clojure has this thing called protocols. You could make it, you can compare it to interfaces a bit if you were to talk about Java, but they are a simple tool which allows you to inject different behaviors in different contexts, allowing a certain level of mocking and stubbing, which simplifies.
Okay, so it's like fakes or something.
Kind of, yeah, I think, yeah, fakes.
Okay, thank you.
Hello.
Hello.
If you were to start a new startup, would you use Clojure instead of Rails now?
It depends on the problem to solve and people available, I think. Hard
okay,
to
so
tell.
So it's not a simple decision for you now.
Excuse me?
It's not a simple decision for you to go with Clojure always? Okay.
I think that Rails allow you to solve a lot of problems very quickly, right? That's certain. But I think that as soon as Rails wouldn't match the problem I was trying to solve, I think that Clojure would be the obvious choice by now.
Any more questions?
If not, you know where to find me. I'm here today, tonight, and tomorrow. Okay. In this case, thank you once again very much.